In this next section, we're going to explore the concept of odds. Now, you might hear this terminology used quite a bit. People talk about the odds of winning the lottery, or the odds of being struck by lightning, or the odds of the Cubs winning the World Series. Odds also talks about the likelihood of something happening, and it is related to probability, but odds and probability are two different concepts. And a lot of times they're confused, and when information is reported, it's actually being reported as odds, but the numbers actually correspond to probability and vice versa. So in this section, we are going to explore what odds actually is, and how to compute the odds of an event, and how odds and probability are related to each other. Now, a probability can be thought as a ratio of the part to the whole. So if you think about when we did the empirical probability, the whole was the number of trials, and the part was the number of successes. When we did the theoretical probability, the whole was the size of the sample space, and the part, again, was the number of successes, or the number of times your event occurred. Odds is a little bit different. Odds is a ratio of part to part. Now, there's two different types of odds that we can calculate. We can calculate the odds in favor of an event, and we can calculate the odds against an event. If you want to calculate the odds in favor of an event, you would report the number of ways your event occurs to the number of ways your event does not occur. When computing odds, you can set it up as a fraction or a ratio, but more commonly, odds is reported using the word to, or it can be reported using a colon. So the number of ways E occurs, the event occurs, we can consider that to be favorable outcomes. And we'll set that next to the number of ways the event does not occur, or the unfavorable outcomes. Okay. And we can use a colon in between the two numbers, or we can use the word to. We will not be using the fraction or the ratio in this course. We'll probably always set up our odds using the colon, just to really stress that the numbers we're reporting are odds and not a probability. So if you're finding odds in favor of an event, you list the favorable outcomes first and then the unfavorable outcomes second. If you're doing odds against an event, you would list the number of ways the event does not occur, or the number of unfavorable outcomes first. And then you would put your colon, and then afterwards you would list the number of ways your event occurs, or the number of favorable outcomes. So notice if you're going to be doing odds in favor, you list the favorable first. If it's odds against, you list the unfavorable first. So let's see how this relates to actually setting up odds. So in this example, let's find the odds in favor of rolling a 5 on a die. Now, if you're going to be doing odds in favor, remember you're going to list the number of ways the event occurs first, and then you're going to list the number of ways the event does not happen, or the unfavorable outcomes. Now, when you're doing this, you still do want to keep in mind how big your sample space is. So when you're going to be rolling a die, remember that there are 6 outcomes total. Okay, so just keep in mind how big the sample space is. Now, out of those 6 outcomes, how many of them satisfy this event of rolling a 5? Well, only one of the outcomes, right? Specifically getting a 5. So that'll be the number of ways that your event can happen. How many ways does this event not happen? Or how many unfavorable outcomes are there? So when you roll a die, how many ways can you not get a 5? Well, specifically, you can get a 1, a 2, a 3, a 4, or a 6. So there's 5 ways that this event does not happen. So that's how we set up our odds. The odds in favor of rolling a 5 on a die would be 1 to 5. And when you see this colon, we would normally say the word to. Now let's take a look at a slightly different experiment. We're going to be tossing heads on a fair coin. Again, keep in mind how big your sample space is. When you're tossing a coin, there are 2 outcomes, right? Heads or tails. And again, we're going to list favorable first and unfavorable second. So out of the two outcomes, how many of them satisfy being heads? Only one of them, right? When you toss a coin, how many of them satisfy not being a heads or unfavorable outcomes? Well, that would be tails, right? So there is one way that heads is not satisfied. So the odds in favor of getting a heads when you flip a fair coin would be 1 to 1. Now I also want you to notice when you set these up, if you add how many ways that your event can happen to how many ways your event does not happen, when these are added together, they would add to how big your sample space is, just to make sure you've accounted for everybody. And that should make sense, right? So when an action happens, either the action happens or the action doesn't happen. Right? So, and then those would be account for everything that's possible in your sample space. Now, those are setting up odds in favor. Let's take those same situations but do odds against. So what would be the odds against rolling a 5 on a die? Well, if you're doing against, you're going to list the ways that your event does not happen, and then you're going to list then the ways your event does happen. So if my event is rolling a 5 on a die, and again there are 6 outcomes, how many ways can this not happen? Well, there are 5 ways it does not happen. And there's one way it can happen. Okay, so the odds against getting a 5 when you roll a die would be 5 to 1. What about the odds against getting heads when you toss a coin? So again, it's going to be unfavorable is going to be listed first and then favorable listed second. So when you toss a coin, how many ways can heads not occur? Well, there is one way heads does not occur, specifically tails. So we list that count first. And then how many ways can you get a heads when you toss a coin? Well, there's one way you can get a heads. So then the odds against getting heads on a fair coin would be 1 to 1 as well. So all we do when we go from odds in favor to odds against is we just flip which count we're going to list first. And again, even if it's odds against, if you add up the number of unfavorable outcomes plus the favorable outcomes when they're added together, they need to equal the total number of outcomes in your sample space. So let's see this in action one more time. So here's a spinner. Assume the spinner cannot land on a line. Determine the odds against the spinner landing on green. Okay, so this is the event we're considering, and we want to find the odds against. So because it's against, we're going to list the unfavorable outcomes first, or the ways that green does not happen, and then we're going to list the favorable outcomes second, or the number of ways green does occur. Now notice each sector in the spinner has the same area, so each sector is equally likely. So when you spin the spinner, there are 8 outcomes total, or 8 sectors it could land on. So how many ways can it not land on green? Because we want to find the unfavorable outcomes first. So how many of these sectors are not green? 1, 2, 3, 4, 5, 6. So 6 of the sectors are not green. And then how many of these sectors are green? 1, 2. Okay. So again, when we add these up, they add to 8, which is the total number of outcomes in your sample space. Okay, so that helps us make sure that we've accounted for all of the different possible outcomes. And then we are actually going to simplify this much the same way we would simplify this if it had been a fraction. So 6 to 2 can be simplified to 3 to 1, because both of these numbers is divisible by 2. Okay, so this would be our final answer. The odds against the spinner landing on green would be 3 to 1.